There we go.
Hi. So I'm chairing this session. I mean, you are all remotely connected, so I'm very sorry about that, but I'm happy to see you guys anyway. So the session that we are going to open now is the one on education and upskilling. And basically, I have Peter Flack, I have Barry O'Sullivan, connected Mohamed Chitwani, Nicolò Cesabianchi, and Ioannis Pitas. Okay, so um, let me just say a little bit of a background. I mean, artificial intelligence is really transforming our society, and it will be basically used in many areas of, I mean, industry, public services, and public administration, and so on. Basically, there is a report by McKinsey that states that in 2030, 30% of jobs will be lost or replaced by artificial intelligence. And this is inevitable, you know. So the thing that is that we can so that we can manage in a way is to deal with that. So we have to accept that this will happen, and basically, we need to rethink completely about education, reskilling, and upskilling for basically educating those guys that are still studying in universities, but also in schools. But also we have to think that nobody can ever stop studying. Okay, so after the end of the university or of the school course, we always have to, you know, to stay updated and to reskill or upskill. So it's essential that we discuss now about first of all, how can we do that? Okay, so is there a strategy? Can there be a European strategy for dealing with this important problem? So I have proposed to the speakers some guiding questions. Okay, so the first part of the panel will concern education. And the second part will concern reskilling and upskilling of the workforce. So I have kind of, you know, thought about a couple of questions, three questions that I have sent to the speakers, so that they will, in a way, kind of answer to these questions. And then if you, of course, guys want to interact also from the audience, feel free to do that. So the first thing is that the first question is that if there are gaps that need to be filled in the current AI education system to create a new generation of experts that could enrich the industrial ecosystem. So do we have to rethink about our current way to teach AI in courses that are science, technology, engineering, and math? So the main courses that provide a background for AI. Of course, it's very important also to talk about non-STEM curricula, because, you know, in the future, basically, we will have many doctors that will use AI, many people working on agriculture, people working in mechatronics, and they will need to know something about AI. Of course, maybe not that deep as for STEM courses, but it's very important that we teach people that will use at some point artificial intelligence, what they can do with that, what they can exploit from artificial intelligence, how can they, for example, extract value from their data, how they can create their own tools and solutions. So I mean, also creating these kind of AI courses for non-STEM curricula is extremely difficult, I would say. So we really need to think about that. And third is I would like to know from the speakers if there is any good practice around. So this is the guiding questions of this first part of the panel. So I will ask, I mean, you guys in any order. So if you want, I can call you if you want me to give you, I mean, an order for talking. But or if you can self-organize, is really welcome. So that's the first part. So for 30 minutes, let's talk about this part, and then we will switch to the skilling and reskilling part.
Sure.
So please.
So do you see me now?
No.
So anyway, you don't miss much.
We know you by now.
We know you well. So I guess maybe I can kick off. I suppose, you know, the questions are really important, and I think they are the right questions. I think I'm not sure if I want to answer them sort of individually, but I think we certainly, you know, skills are the number one issue, I think, for the AI community broadly in Europe. I think particularly the uptake of AI. I think every country in Europe there are many reports that sort of tell us that the big concern that companies have and the big worry that they have, and the reason why there isn't more AI being done in the commercial world is because of the availability of skills. Now, maybe that's true, but I think it is. I certainly think it is. And so we do need to create more skilled individuals in AI. Now, that doesn't necessarily mean that we have to educate them using the standard undergraduate degree and master's and PhD. I think, in fact, we need to dual skill people. I think there are people from different disciplines, you know, who can very easily be given some skills to help them on their AI journey. And so, you know, if you look at things like the Elements of AI course that Timo Roos and others have created, I think that's a really tremendous resource. So I think we can be, we do need to create new content. We do need to teach people in new ways, but we should think about this as upskilling many people, as well as taking people through the standard routes. I'm chairing a committee for the Irish government on AI skills, and we're just about to, you know, publish our report on that. And we're largely saying these types of things, that we need to have many different routes for people to become skilled in AI. And there's a diversity, everything from traditional curriculum at university, but lifelong learning and upskilling are going to be really part of this, especially as people become, you know, more conscious of their interactions with AI and the need for, and that as more people's jobs become impacted by AI. So I think, you know, we need to be open-minded and flexible here. Thanks.
So just one further comment, which I think might be useful to frame the discussion, because AI is this new thing and innovation, and it's going to change the world, and we've heard it all many times before, and of course it's true. But that doesn't mean that we should forget what came before us. And I think AI has a bit of sometimes a regrettable tendency to do that, and to think that things like there wasn't ethics before we looked at ethics in AI and so on, which of course is misguided. So I was thinking in that vein, and trying to, are there role models? Are there other subjects that we can learn from? And in fact, I ended up with mathematics. So mathematics is a research topic in its own right, but most people are not becoming mathematics researchers, yet they need mathematical literacy. And we take that so seriously that we teach, you know, a bit of mathematics in schools, and then secondary school, we go a bit deeper. And then at university, I studied electrical engineering, not mathematics, but I got a very solid training in mathematics. And I think that is quite a good model for AI as well. So most people will not become AI researchers, but many people will become AI users or appliers of AI technology. Or as a society, they need a certain AI literacy to understand what the technology is doing and what the risks are and the benefits. So I think that could be a good starting point, because we teach mathematics at all levels for very good reasons. And so I'm not saying AI is now what mathematics was, but I think it is a useful role model to think about how should we deal with it. The challenge, of course, is that mathematics education has evolved over many centuries, and now we don't have the time to let it evolve in AI to take as much time as well. So we need to do that more quickly. But I would be very much in favor to try and see what we can learn from the past before we kind of invent all sorts of new structures. But one new structure that I do think we need, we basically, at universities, we need to recognize that AI is now a subject in its own right. It's not a subfield of computer science anymore. It is its own topic. We need departments of AI. We need schools of AI. We need faculties of AI, depending on in which country you are. And we need courses, undergraduate courses in AI. That seems to be completely clear to me. So that is something that we need to work towards. Thank you.
Okay, the reason I jumped in is because Peter put things in the right way. First of all, I think that we can now speak about AI, science, and engineering. Whether now it's going to be a domain, I mean, a discipline by itself, or whether it could be a subdomain of information science and engineering, we can debate on this. But certainly, I think that the old structure of computer science, electrical engineering, and ECE departments, it's obsolete now, because I think that we need a major overhaul of these departments. And most parts of computer science and electrical engineering can go together into information science engineering or any other appropriate term. That's thing. So maybe this is a big vision, but anyway, this is what I would propose. This is thing number one. Thing number two is that having a look at the past, I think that the data increase at an exponential way. We cannot really cope as humanity with data increase at this rate. Knowledge, it seems, it increases at a linear rate over time, which is manageable in a sense. But then we cannot absorb things in 4 or 5 year studies. So what we can do, I think that we should provide a very strong mathematical background. Traditional electrical engineering departments have a strong mathematical background, but the CS departments don't. They discovered linear algebra only recently, for example. And the reason for having strong mathematical background is to create skills to abstract and compress knowledge, because without abstraction to higher entities, conceptual entities, and compression, we cannot really survive. That's my idea, at least. And it's of course we can use all tricks that, for example, we can skip all the domains. Euclidean geometry, people don't really do much Euclidean geometry these days, so they focus on analytical geometry, which is good. We can do such things in computer science and in AI science as well, but that's not really enough. We really have to conceptualize things at an abstract, at a more abstract level, and compress knowledge if we want to survive. So these are my points. So how can I? So how can I stop sharing now? Okay.
Well, I
go ahead, Nicolo.
Yeah, I like a lot the idea of viewing AI as a discipline, as an area per se, as Peter was suggesting. And although it's naturally, I mean, it's an area at interface of many disciplines. I think the role, I'm a computer scientist, so I'm totally biased. I'm going to be, partial here. What I'm saying is that at the end of the day, AI systems are implemented on computers. robots, but there is a coding and algorithmic aspect that is not. I don't view it as something that can be abstracted from when you're talking about AI. But again, this comes from my own background information. You might have a broader view on this, and there is certainly an interface aspect which is the strongest of any other discipline I know. I don't know many, by the way, but anyway, I like AI because we end up talking with the mathematicians, statisticians, computer scientists, game theorists, psychologists, jurists. I know I'm getting an echo. Very strong echo. Okay. Can you, is only me that hears the echo? Okay, it's gone now. Thanks. Okay, and I think this is a strong, a rich aspect, this interdisciplinarity and being an interface of many different disciplines that is really key to AI. And it's also a problem because you have an identity problem now. So you have mathematicians say, okay, AI is something, you need mathematics to do AI, so AI is ours. You have physicists who say, okay, wait a minute, but we can figure out AI. Okay, we figured out many things, we're going to figure out AI ourselves too. And, everybody has his own point to make on that. And, so I think there is, again, the coding and the algorithmic aspect is something that is central to AI. It is something that it is also central to a way of thinking, a mindset, which I think is extremely useful in education. And I would start, if I think, okay, let's teach AI in high school, I say, what? AI in a school, how is it possible? What are you going to teach? But then you think about like clustering. Clustering is a super intuitive concept. You can look at it geometrically. Everybody has some basic geometrical intuition, and and you can basically in 10 minutes, I guess, people can figure out k-means by themselves, as an objective function. And maybe the smartest will be able to figure out Lloyd's algorithm because it's super intuitive. So this is something that you can arrive at by algorithmical thinking, and then you have a coding part, which is important, but I mean, the pseudocode will be enough, but definitely the coding will get we have beautiful tools now for interactive coding like Jupyter that integrate the coding, the graphical outputs, and the LaTeX. And these are amazingly effective in order to teach these things, as Ioannis was suggesting, in a compressed way. You can really, have a high throughput and teach very effectively these things. Okay, I will stop here. I didn't want to make any. Then I will have something to say about good practices afterwards, but I'd like to stop here now.
Okay. Thanks for what you said. I fully agree of what has been said before, but we should also be careful for some of the stuff that because as it has been said, we need also to discuss with the other disciplines, and that's a risk because now you could have let's say side effects or negative side effects. For example, we see a lot, even from our students or even companies that are working, for example, in natural language processing or speech or image, but they don't know at all language. For example, language is quite specific. They don't have any expert about language, probably because they don't need for the methods that they employ in AI. They don't need to do. Other example is probably, you heard about that, now it's something that we see a lot, is programming without coding is also something that we see. So is it something that we want also in AI? is that we should also be with the disciplines and trying to have that in mind. And something also that I wanted to add is that we want also to let's say to train people that maybe in the future to the next generation, so there will be something else. So probably most of the people that are now working also on AI, I mean the senior people, were not trained during their education on AI, but they got the background in mathematics, you said, physics, or any other domain, to be able now to address AI. And I think that's also things that we should have in mind for the future of the stuff, and also to try to make it for people that are not now grounded in AI, but they could still address these kind of topics.
Yeah, if I could just come back to something I was saying at the very opening, I think I agree with absolutely everything that's been said. I think this is really important, and I really like Yannis's idea of AI being seen as a separate discipline, and I very much like Peter's remark about there being the need for AI departments, and these are absolutely these will be multidisciplinary endeavors, of course. But I think we do need, in the discussion about skills and upskilling, we do need to think also outside of the sort of technical education of people. And there are many stakeholders here that we do need to skill and educate. So it's not just those who will innovate in AI, the people who are going to build the startups or do the science or so on, but there's also the people who, the ordinary person on the street who's going to have an understanding of AI. There's the policymaker who's going to have to introduce and understand the impact of their decisions on, be it funding or regulation or legislation. But there are also, the users of AI, and I think these different sort of personas, these different groups who demand to be able to use AI, I think they need to be treated differently, so that they get the skills that they need. As Peter said in his remarks, not everybody is going to be doing the science of AI, and that's absolutely true. So I think we shouldn't lose sight of those other cohorts, and particularly in relation to ensuring that there's sufficient skill out there in the community broadly, so that the next time that industry are asked what is the greatest obstacle to them adopting AI, that they're not saying skills, that they're saying that we have the skilled people, and that kind of thing needs very dedicated focus. And of course, I agree with everything that everybody has said here already. Thank you.
If I can just interrupt you, there is a question from the audience. Can you come here so that maybe you can address this question?
I'm Vincenzo from Siemens, and I have a question about people that want to approach the AI not as a student or as a research. And which is, in your opinion, the best methodology to approach that kind of people? Make things simpler or just go beyond the basics?
Yeah, I spoke last, but so I don't want to speak first.
Well, I have some ideas on this. It depends, of course, on the type of audience. If it's general audience that wants to become knowledgeable about AI, then we need books and other multimedia material like videos that are sort of trade books, I would say, which means that the level is not really lower. It's a level, of course, without mathematics, but with accurate description of what's going on. Because one of the problems we have nowadays in many textbooks is that the notation that we use and the notions are very vague. So this has to be avoided. So we need good literature that is appropriate to the general audience, and yet that these books should be and other materials should be accurate. That's thing number one. Now, when it comes to people that are not really AI scientists, but they are, let's say, mechanical engineers that want to to get familiarized with AI, science, and engineering, then I think that the most viable tools is lifelong learning. So they should attend short courses in a synchronous or asynchronous mode, personalized to their needs, and then the level. Again, we need specialized material for these things, because you have to present them theory, but you have to present them applications as well, because otherwise it's not going to be appealing. It's a major work that has to be done, but we have the tools. So we just need money and effort to produce these tools. That's all.
Yeah, if I can jump in, like obviously there are, so Vincenzo mentioned he's from Siemens. I guess, obviously the kind of training you give to people with, who are coming from industry or have specific industry expectations about their skills, I think it's obviously important that they're tailored to the specific role that person plays. And there are lots of very fine examples of resources out there that people can use to help those people. So obviously, I mentioned the elements of AI. I think, frankly, everybody should take the elements of AI. But of course, the elements of AI is only about machine learning, really. So, but there are other areas that we need to expose people to. So, our responsibility on the education community, the academics, like those of us on this session, is maybe to produce other similar courses in other areas of AI. So Michaela and I are constrained programmers, so maybe we should be doing an elements of constrained programming or something. But also there are, Udacity and these types of organizations, Coursera, there's some fantastic content out there. And I suppose one thing we should think about doing, and maybe this is something that AI4EU can help with, is to identify the kinds of roles that Vincenzo has in mind, the kinds of skills that he needs people to have, and that we then curate for those people a curriculum of courses that they could take in their own time to get the skills, and maybe also point to more formal things. And we'll mention IDA later, but I think if on the AI4EU platform, we could say, well, if you're a telecommunications engineer, these are some of the courses that we recommend that you take, or something like that, or that we create them in Europe. And we shouldn't be shy about the fact that some of this content will be produced outside of Europe. So, we take the best content, but I think that's probably something that we can help those communities to do. So there's already. So I suppose I do a lot of training to industries. They're very specific about what their requirements are, and I think that's great. There's fantastic content. We can produce new content, and the platform, the AI4EU platform, could be a way of sort of gathering together and curating those sets of Coursera courses, those sets of online courses that people could take in those areas, and come with some, create a community around that kind of learning. Thanks.
I wanted to just come back to something that Nicolo alluded to when he talked about computational thinking and sort of general literacy. I think there is a huge challenge here, and actually somewhat tongue-in-cheek, you can say, well, AI, a lot of it is about Bayesian thinking, a lot of it is about logic. And actually humans are terrible at either of these things. Our intuitions are all wrong. We make logical mistakes, we make mistakes with Bayesian reasoning and so on. So that's an important starting point, that even I need to think, I probably need to apply Bayes' theorem here somewhere. So my intuition is probably wrong. I need pen and paper to work it out. And with COVID, we see the same thing. People just see the numbers flying past and they make all terrible mistakes. So I think the challenge that we have is huge. I mean, to get people up to the level to understand what these algorithms do, that is not something, let's write a few textbooks, let's do some demos and so on. It's a huge challenge. We have to recognize that, because people make all these, people don't have the intuition for computational thinking, statistical literacy, data literacy, algorithms and so on. So I think that's where I would start. We really need to we need to start at the beginning end. If we now start to educate, let's say, secondary school pupils, I mean, it will take a long time, but then we have a chance to reap the benefits of that later. If we ignore that, and if we're just going to say, oh, you're a mechanical engineer, oh, I can sort of reskill you, that solves a problem, but that doesn't solve the bigger problem that we have there, I think. And the other thing that I would say, and I know within the Taylor project, I keep on saying this, but we need to use our own AI tools. We need to build demonstrators. We need to kind of build learning environments that have AI built in. And so that if somebody does a bit of learning, that then the system at the end says, do you know why I asked you these questions? Because the AI figured out that you need to be tested on this kind of knowledge. So we really need to put our money where our mouth is, I think. And AI4EU platforms like that have a lot of promise to achieve exactly that, I think.
Yeah, and if I can add just a few words to what you were saying, Peter, I think that there's also a problem in, getting the right expectations. So some people might not be ready to systems that actually change their behavior as they use them. So, because this is, I don't know, we are now, for us, it's kind of obvious, right? I mean, I'm doing machine learning, so I want the systems to adapt. But most people don't like it when their interface move under their feet. And so I think there's also an issue of sort of scalability in the sense that the degree of autonomy should somehow match the expectation of the user, because we cannot expect all users have the same level of readiness to these kind of technologies that are extremely complex, because people tend to project onto these technologies things that we don't even imagine, because you see them as black boxes. So you just, what the hell is going on here? This thing is actually doing something I didn't expect. No, this is scary. Yeah, this is something that, a point that I was completely aware, but I think is also important.
I just want to say one more thing, because Peter triggered this part. We do machine learning, all of us, let's say, and then we have human learning, and we have many theories about human education. So why don't we have then a unifying theory for both for human learning and for machine learning? This may sound far-fetched, but who knows, I think that it's a very interesting discussion to theorize a little bit and philosophize. And of course, this is going to propagate downwards to high school and also to elementary schools as well. And we need a very, very good theoretical background to be provided at these levels as well, both algorithmic and mathematical.
And guess which one of us is from the Aristotle background to race philosophy. Well done, Yanis. I think that's that's
I like to philosophize at times.
Well done.
So is there any, to answer to the third question, I mean, is there any good practice around that you have seen and that you think is worth replicating, or think about something that is already implemented around in Europe and it's good?
Well, Coursera. I'm just joking, but there is some good material there, and we can produce more. In fact, I would dare say that we have to think in a different way on how to publish this educational material, because it does not pay off to authors anymore, because these things are easily copied. So what about creating something like public goods? So there are bodies like, let's say, Siemens, that wants to fund an author to produce very nice material, and then this material is publicly available. And we can have a book series or video series or material series, and this is going to help. It's going to boost Siemens image as a marketing tool, but at the same time, it can help lowering the digital divide, for example, because it's going to be used for everybody for free.
Yeah.
Like obviously there are very good examples of education programs across things like Marie Curie networks and these doctoral academies. Peter runs a centre for doctoral training in the UK. I run a similar centre in Ireland, and so these are cohorted. Well, at least in our Centre for Research Training here in Ireland, which sits across multiple universities. You know, we have funding for 120 PhD students, for example. We bring them in; they're cohorted. They live in different research labs across the country, but we bring them together. We sort of serve them as a single community of learners. And there are examples of that all over Europe. But of course, that addresses PhD education. I think we do need to focus on all levels of education in a very specific and purposeful way. And I'm not sure that, I think there's great opportunity there. I think there's tremendous gaps. And of course, you know, the European Commission over the next year or so has a series of calls specifically targeted at education. So there are some very specific opportunities for us to think about that sort of thing. Like obviously, one of the things I often wonder about is whether there should be a specific set of skills that we require people to have to claim expertise in AI at different levels. So, you know, I'm not you know, maybe like a certified AI something, engineer, developer, expert, scientist, whatever the case may be. And I think, you know, we can look to other fields for how skills are certified and so on, and how those other fields, you know, for example, in the field of health, how continuous professional development is sort of documented and so on. And I think we need a structure like that for AI. I think we need a structure that sort of certifies that the person who claims to be an AI expert is an AI expert. I'm not sure what people think, but every time I go onto LinkedIn, I kind of lose the will to live when I see the kind of comments that are made about AI. You know, it's not the field that I recognize. And I think we need to sort of stamp that out a little bit, because I think there's a lot of misinformation, maybe not intentionally circulated by AI, but there's a lot of sort of inaccurate information that's circulating because people don't know the field. And so I think we should think about a European sort of certification that says, well, if you have a master's in AI or an undergraduate degree in AI or something, then you can make a statement about your expertise. And in other fields, you know, if you're a doctor or you're an engineer and you want to develop your skills in AI, that there's also a structure there for sort of documenting that. And I think if we can think in those ways, that's also another way of sort of structuring the whole education program. And I think that would be very, very beneficial.
I totally agree with that. I think this is extremely important. And I think we are in the position of doing something along these lines in terms of AIDA and the likes. There's the example of the ACM computer curriculum that is very well articulated and is a reference international standard for computer science curricula. And we can definitely, I think, set up a European certification, a sort of a stamp that certifies that a certain program, a certain degree program, covers a core curriculum that is considered to be necessary for AI. I totally second this suggestion. I think this is the time for doing it. Otherwise, it's going to be too late.
So, well, thank you. I think that, I mean, you have touched a very, very important point for what concerns education. I would like to focus on the next 20 minutes, that is the remaining time for our panel, the matter of upskilling and reskilling. So we have, so in this case, I mean, I have kind of devise a couple of questions. One has already been touched by the previous question by the Siemens
Victoria.
guy. What about, so like the general knowledge for the society about AI? Okay, so there are, of course, we have to improve the current skills of people that are working in companies, so that they can, in a way, change their skills and adapt to the new technology that is coming and is becoming more and more pervasive. And also, I mean, there is also a matter of awareness in companies, because many of them basically are not yet aware or ready to take the challenge of upskilling and reskilling their workforce, but also society. So since AI is becoming pervasive in our everyday life, also having people that general people that knows what is AI for, also how to avoid AI being considered as a dangerous technology or something like that. So these two parts, I mean, like, are very important, I think. So I would like to ask your opinion about the two things. So one is about the general the public, and one is about companies and the reskilling and upskilling part. For example, one thing that I would like to mention is that so at the University of Bologna, we are trying to create these AI pills that are short courses, like 10 hours, for university professors that are not working in STEM in STEM courses. So that, for example, for the Faculty of Medicine, for the Faculty of I don't know, agriculture, agri-food, and so on. So we are devising specific courses for them, using, by the way, also the Jupyter tools that are really very effective. So, so this is a way to reskill and upskill these people that are then, I mean, kind of being able to then teach their students what they can do with AI, basically. So, if you want to give me your impression on that and your opinion on that, it would be nice. So again, you perfectly self-organize.
Well, I suppose, you know, so focusing on the public, I think, you know, there are specific things that the public needs that maybe they're not the same skills that a researcher or an innovator in AI would require. You know, it's I think you know, the general public need to understand, I suppose, you know, what is AI? I mean, rather precisely. And I think, you know, I don't want to sound like a public advertisement for the elements of AI, but the elements of AI do that. It's an example of how that can be done so really beautifully. You know, that people can really get their hands on the concepts in a way that allows them to understand, oh, well, this isn't magic. You know, this isn't something I need to be afraid of. You know, it's these are very particular kinds of algorithms, and they do particular kinds of things. And I see that, and I think we need more of that kind of content for the general public, that they can, you know, instead of having a book club, they can have an AI club. I think the other thing is that we do need to try and improve the sort of numeracy and problem-solving skills of the population. And Peter's absolutely right. That's not an easy task. But I think you know, there are lots of you know, we need people to understand, you know, sort of basic sort of mathematical concepts. I mean, very fundamentally, and they don't have to be taught in mathematical ways, so we don't have to frighten them. You know, I think there are ways of getting some of those concepts across. And I think if we could get to the point where the general public can distinguish between sort of fact and fiction when it comes to AI, we'll already be a long way along. And I think one of the things I do worry about from a European point of view is that we have become a world leader in negative public debate about AI. It's all fear. It's robots taking your job. It's how all these algorithms have gone wrong. That every algorithmic thing that goes wrong in the world is because of AI. It's not because of anything else. And I think we have to counter that, but the public need to be able to understand, that the limitations of all software systems. And AI isn't this sort of a projection of all of our technological fears. I think so. It's really interesting to hear about those AI pills that you're doing. But I think that's exactly the right thing to do. While someone at university can consume 10 hours, maybe a mini pill is what's required for the public. But I think it's a really, really nice idea. But it's a sector that we really have to work with, because after all, you might remember a few years ago, maybe 10 or maybe 20 years ago, there was this European computer driving license, this ECDL. I think we kind of need something like that for AI, sort of a European. Now, I see Nicolo's sort of grimacing at that, but we need to be able to have some materials that can really explain to people, the ordinary public, that they can consume and understand what AI is. Now, maybe the elements of AI is the prototypical example of how one would do that. But we do have to educate the public, and in a different way. They need different skills. Thanks.
Yeah, sorry, I was grimacing because I didn't find ECDL like
I know, of course,
the most successful.
Yeah, sure.
But you are right. I mean, there is a wonderful series on YouTube. It's called Kurtz Act. I'm getting the pronunciation wrong, probably. It's in a nutshell, right? Kurtz Act. And this is like an explanation in 10 minutes of anything from the Big Bang to how the immune system works, which is amazingly complicated. But they do a job which is, I think it's incredible. I mean, it's really, really amazing, because that's a really super compressed, very effective transmission of information through simple cartoons, and it's very entertaining. And it's, I don't know, I think that's a great example of, I mean, once you see one of them, you're completely hooked, and I'm waiting for the next one to come out, because I'm learning a lot. And that this is in most disparate areas. So I think that something like along these lines would be very good. It would require, I mean, there are many people with amazing skills at doing this. It would require, I think, a modest investment. And yes.
I agree. For the general public, well, maybe I think we can. Of course, what has been said is really relevant, but probably elements of AI and things like that are useful, but they also, I mean, need to have things that are concrete in their life, and just thinking of being aware what is AI in their life is important, and how they can interact. Because one of the risks, and what we want also to have, and this is true also for people that are not in AI, even in AI, but more in when you don't use and manipulate and do experiments with AI, is that you could have a wrong interpretation of the results of the way it's working. And it's something that we see in general public, and it has been said, the COVID, the numbers that we have and things like that, when you don't know, you just see numbers and you don't know how to interpret that. And that's the same. If we get just the fact that maybe we don't know all the details, but still we know how to interpret the results, and to be aware that this is an AI, that will be something really important. And regarding people, I'm coordinating a project that is a micro project that is about human-machine interaction in schools. And you see that with teachers. So we put robots, virtual agents in schools, and you always have this question: who is replacing who? And this is not the question. We want to build something else, and the only way of doing that is that there will be a good interpretation, a good understanding, even from the teachers, about the outcomes of that, and so they can provide some scenarios that make sense. Even if they don't know all the details, they will know that, because we could have wrong interpretation and in schools, but this is something that I see also with medical doctors. They try to put some of the tools that they have in AI, from AI in the domain, and this might be wrong because this is quite easy to make also AI wrong, in particular machine learning, by doing that. So that's, I mean, a risk. And if we have to put something very, of course, there are a lot of priorities, but this one is one of them. Thank you.
I think an important issue was touched by Barry with respect to fear, and I see two issues there. The easiest one is when it comes to professionals that we have to be reskilled on AI. They are afraid they cannot grasp these notions. They find that this is very difficult for them. I think that this is an easy case because if we address them properly, they have the background to understand, but we have to educate them. There is, though, another issue related to fear, which is much more general, and it's really, it can shake the foundations of our democracy, because I have thought about it, and I think that internet as it is right now and social media, they promote fear. And they promote fear because people, in the past, they were not really invaded in their bedroom. Now the world is in their bedroom, and they are bombarded with information. They don't have good information to grasp this information. So essentially, they have the fear of the unknown. Okay, and then you have all sorts of problems coming out: technophobia, misinformation. So this is a major issue, and I think that we have to address this issue. We have to educate the general audience in the short run, and in the longer run, we have to restructure our education system in such a way so that they can grab basic notions. For example, as Nicola said, the notion of clustering is a very simple notion, okay? But yet it's very important. It can help them organize their mind. So this has to go maybe down to the elementary schools. Because right now, whatever they learn about programming in high school and in the elementary schools, to me, it's garbage. Because they don't do basic things. They do technicalities that change every 3 years or so. So essentially, they just get obsolete knowledge. Maybe I'm too strong in my arguments, but anyway.
No. I think you're right.
That's the.
No, I think you're absolutely right. Yeah, like there's some, just following on from that, there's some very interesting stuff I saw in Nature a couple of years ago that showed that false information and fear propagate much more quickly and significantly through social networks than factual information. And so just support, this phenomenon that Yanis is pointing to has even been proven, scientifically that this is that this is so, and it's something that we really need to deal with.
This is exactly correct, because then it touches psychology. That's the nice thing about AI. We interface with psychology, we interface with sociology. So can we claim that this is a new science? Maybe it's more a new science than data science or web science. I don't know. We have too many sciences these days.
So maybe, oh, sorry. Yeah, I just wanted to say a couple of words since Michela asked us about upskilling for industry. So maybe I can say something that I guess Michela knows very well, because it's in the Italian AI strategy. This is two proposals for upskillings that I think are very reasonable, and they are an example. At least this is not implemented yet, is the AI strategy for the next few years in Italy. And this is about, in getting as many PhD profiles in industries with salaries that are competitive, and therefore they are not, there's no much incentive to go abroad. In Italy, we have a lot of, brain drain problems. And so the idea is to provide tax breaks for recruitment of high salary AI profiles in industry. And the second suggestion is to strengthen at the local level the ecosystems that we have in different parts of the country by creating public-private partnerships that are targeting knowledge transfer and startup creation. So somehow you want to have these education hubs between universities and companies where there's a very effective knowledge transfer because in somehow part of the company is outsourced in some university lab. So there's a very tight connection there. Okay, this is just to touch upon this topic that Michela raised.
Thank you for mentioning, Nicola.
As we are close to a close, I just want to tell you that next summer we're going to organize this AI Melanology workshop, and hopefully again Nicola, I hope he's going to help in this organization, and any one of you, we can, for example, devote half a day or even the entire day for AI and education, because it's such an important topic. But I'm going to be back to you on this.
Okay, so we are basically in the last part of the panel, so we are basically reaching the conclusion. I know that we have a question from the audience, and it's from a student. So who better than him can ask you something? If you want to come here, you can so that then they see your face also.
Hi, Samuele Maio, University of Bologna. I had a question related to education, although some of you have already partially answered it. Many of you propose to introduce AI-related topics at a younger age, such as at a high school level, etc. The thing is, from a practical point, how will you be able to integrate such topics with existing curricula? Like, should we just increase the overall workload, or would you go for example, sacrificing existing subjects or integrating them with the existing courses, such as making AI part of the math subjects, for example? Thanks.
Yeah, so maybe I can just comment on that quickly. In Ireland, we have, so in the high school, the last examination, the last cycle that students take is called a leaving certificate. It's either O or A level in the UK, I'm not quite sure. And recently introduced into that program is a computer science module. And so like an obvious place to start doing some of this is in that module. So people who take that course can get exposed to AI. But in fact, you know, I would go so far as to say that there should almost be an alternative there, that either students do the general computer science one, or that a new curriculum is introduced that focuses on AI. Of course, you know, AI concepts can be taught in mathematics as well, of course, and maybe they should be. You know, there are applied mathematics courses. And so I think with some revision or updating of existing curricula, we can actually include some of this type of problem solving and so on that's necessary. So I don't think we should think of it as replacing at great cost other things. I think there's, you know, through updating and so on of existing courses that people take, you know, you can get this content in. Thank you.
My idea on this is that the programming courses and other computer science, let's say, courses we have in high school and in the elementary schools, they are obsolete, and in my view, they are substandard, and essentially they miseducate people rather than educate people. They give them knowledge that is obsolete in 2 or 3 years, so this has to be replaced. We can have a course, for example, on computational thinking or algorithmic thinking that is going to be cross-linked with mathematics, and then you don't need an extra workload. So that's my idea.
Okay. Are there other questions very briefly, because we are basically closing? Okay, so if not, let me warmly thank the speakers that have really, I mean, taken us 1 hour in this very interesting journey between, I mean, education, upskilling, and reskilling, or awareness in the society, and so on. Covering very interesting ideas. So thank you again, guys. And I'm really sorry that you're not here in Bologna with us. But I really hope to see you all soon, very soon.